Okay, so the question number 2 reads, how do you factor x cubed plus 8? Okay, so we're going to use a technique called um, the sum of two cubes to evaluate or to factor x cubed plus 8. Okay, and so the sum of two cubes tells us that the sum of two cubes with a cubed plus b cubed can be factored as such: a plus b times a squared minus ab plus b squared. Okay, so the converse of this is, or the alternative one is the sum of the difference of two cubes, or the difference of two cubes, and we have the difference of two cubes here, and that is equal to a minus b times a squared plus ab plus b squared. Okay, so whenever you're using these two, rules, you have to recognize that your example here is the sum or difference of two cubes. Okay. So x cubed plus 8 can alternatively be written as x cubed plus 2 cubed. And by looking at this, we can use the sum of two cubes to factor this into x plus 2 times x squared plus 2x plus 4. Okay? Oh, minus, sorry. All right, but we can factor this further, and that's what the junior tutor did. So you can only factor this further if you consider imaginary numbers or complex numbers to be part of your set here. Okay, and this is because this trinomial here does not have any real solutions or real zeros, but actually has imaginary zeros instead. So in our answer here provided by the junior tutor, they also considered that there would be imaginary roots, and they further factored down our trinomial here. Okay, so the quadratic formula is going to be used here, and the quadratic formula states that the zeros of a quadratic function can be found by calculating this formula, which is negative b plus or minus the root of b squared minus 4ac divided by 2a, where a, b, and c are the coefficients of our trinomial here. Okay, so we're going to use this in our example. So x equals negative b, which is negative times negative 2 plus or minus negative 2 squared minus 4 times 1 times 4 divided by 2a, which is just 2. Okay, and what we get here is that we get 2 plus or minus 4 minus 16, which is going to be plus or minus root of negative 12 divided by 2a. So as you can see here, that you can't square root negative numbers unless you consider imaginary numbers. So we're going to state that here. So I is equal to the square root of negative 1, and therefore 2 plus or minus root negative 12 can also be the 12 times I divided by 2. Okay. And now we're going to make this into radical form. So 2 plus or minus 2 of root 3 of I is divided by 2. And therefore, our zeros are 2 plus 2i root 3 divided by 2, and 2 minus 2i root 3 divided by 2. Okay, so now that we have found our imaginary zeros, or our solutions, we can plug it into our factored form here. So our factored form, therefore, the factored form is going to be x plus 2 times x minus 2 plus 2i over times root 3 divided by 2, and times x plus x plus 2 these should both be plus 2 plus minus 2i root 3 divided by 2. Okay, right. So this is the entire factored form. Okay. So in the junior tutor solution, they remove the 2 from the denominator. That's not necessary here. but these two solutions are correct. And the only reason why we consider the imaginary roots is because the junior tutor included in the solutions. Usually when you're trying to factor the sum of cubes or difference of cubes, you usually don't actually consider the imaginary roots. You actually stop at this step here. Okay. So other than that, the solution is correct.